about the 211 design, add, and search word data structure. The question is design a data structure that supports adding new words and finding if a string matches any previous adding string. Implement the word dictionary class. The word dictionary initialize the object void add word and add a word to the data structure. It can be matched later. And also have the search function. This function means to return true if there is any string in the data structure that match the word, or false otherwise. Words may contain the dots, where the dots can be matched with any letter. Okay, so which means this one, so I need to skip that to find the next one. This one is also use the try node to start it, and which is different is searching part. We have the container dots here, so we need to use the DFS to skip something, right? So let's say write it first. Plus try and the boolean is word is equal to true. Original is equal to false. Then we can do is we have the global something called try. And then okay, so this one is finished, and for here we same to do the other word. So try node equal to the root. Words length plus here. Then we got the chart current word. Try node next is equal to the per children, like and if next not exists, so which means we need to create a new one. Try node and then connected the current children to the next one. And then per equal to the next. Okay, so this one is finished. Okay, so what's going to do is the search is the DFS and index, and then for the which one is the index, and then for the index start from the 0 here, because we have the tree here. So let's see, we have the tree, right? So for here we need a Okay, so for here we need something okay, so we have the word and index trinode, so we can do something is if word to search this, to DFS search this, and if we encounter some this docked, so we need to skip current level, go to the next level. So this is purpose of the DFS here. So we have to check if the index equal to the word length, the last one. And also we need to check current cur is word, right? We return this. If this, return true, if not, return false. Now char. Okay, so we need to check if this one is equal to the dot. How could we do, right? So if not, we need to try node nest is equal to the children stage minus a, this one, whether it exists, right? So if nest equal to none, it's return false. And if it is, then we go to the next level. Inverse word index plus 1 cur equal to the cur nest. And where if the stop here, it will return the true and then return back. So now we're looking back if this one, right? So we need to go to the next level. Smaller than the 26. Try node nest. Okay, this one is. No, not, it's for the I. Current I. Doesn't equal to none at the same times. The DFS word index plus 1. Nest. If they are return true, then we return true. If not, we which means return false. Yep. So children. children. Okay. Return. Yep. And for the time complex, we created this trinode, so I will say space is O1. And also use the df array. The stack is maybe is also dn. For the space is this for loop in dfs, right? So 26 branch and level, so it will be 26 branch level in level. It will be like this. I'm not sure. I see what's going on. See, it's 20 for a word. Okay, 26 here. Okay. Yeah, and times the m for the undefined words. Yeah. Whatever. It's very close to the O1 time actually. Thank you.